Ghost in the Machine, America's Silent Fury, and the terrifying revelations of the second B-21 Raider, The Dragon Awakens. Not with a roar, not with the thunder of burning propellant, but with an almost imperceptible hum, a whisper of impossible technology tearing through the cold, pre-dawn air above Palmdale. The world barely registered it. Most couldn't. The event was a ghost, a rumor carried on encrypted signals, but for those few, those select guardians of the free world's silent arsenal, and for their counterparts staring into the void from opposing watchtowers, a single fleeting image sent shockwaves through the very foundations of global power. This wasn't just another test flight, this was a declaration, a chilling, undeniable, and utterly terrifying statement of intent from the United States. Delivered by a spectral leviathan of composite and silicon, the second Northrop Grumman B-21 Raider. Forget everything you thought you knew about stealth. Forget the B-2 Spirit, that majestic, albeit aging, silver-winged phantom that has haunted our imaginations for 3 decades. The B-21 Raider isn't merely an evolution, it's a quantum leap. A technological singularity that redefines the very essence of strategic deterrence. It is the apex predator of a new age, and the recent flight of its second prototype, codenamed Spartan by those in the know, has just ripped open the veil on secrets that will send shivers of profound dread down the spines of America's adversaries. This isn't just about a new bomber, it's about the very survival of American air superiority in an age where the battlefield has become an invisible, lethal, electromagnetic maelstrom, the ghost of conflicts past. Why America needs a new phantom. For decades, the United States has relied on a venerable, yet increasingly vulnerable, fleet of strategic bombers. The iconic B-52 Stratofortress, a titan of the Cold War, still thunders through our skies, a testament to its raw, enduring design, but also a glaring symbol of an era fast fading into history. Its venerable airframe, a massive radar target, is a relic, a flying museum piece in the age of digital air defense. While it has been consistently upgraded, it is a beacon for modern integrated air defense systems, IADS. Then there's the B-1B Lancer, a supersonic swing-wing marvel, stripped of its nuclear mission, now serving as a conventional workhorse, but still optimized for a fight that's no longer on the horizon. It's a fast-moving target, but a target nonetheless. And finally, the crown jewel of stealth, the B-2 Spirit. For 30 years, it has been the unchallenged king of deep penetrating strike, an exquisite machine of unparalleled low observability. But even the B-2, born of the late Cold War, now faces an existential threat. The world has changed, the shadows have deepened, and in the chilling strategic chessboard of the 21st century, adversaries are no longer playing by the old rules. We stand at a precipice. The rise of peer and near-peer competitors, particularly China and the resurgent Russia, has brought with it an arms race of unprecedented scale and sophistication. These nations are no longer simply buying off-the-shelf systems. They are innovating, pouring trillions into developing anti-access, area denial, A2AD capabilities. A suffocating, multi-layered net of advanced surface-to-air missiles like the S-400, the S-500, and China's formidable HQ-9 family. These systems are networked, mobile, and lethal. They are backed by long-range interceptors, sophisticated radar networks operating in multiple bands, and, most terrifyingly, hyper-advanced infrared search and track, IRST systems. Imagine a future conflict in the Indo-Pacific, vast, unforgiving expanses of ocean, heavily fortified islands bristling with sensors, and a virtually impenetrable shield of missiles designed to lock out any encroaching force. This is the tyranny of distance, compounded by a wall of digital fire. An aging B-52, even launching standoff missiles, would be detected hundreds of miles away and unceremoniously swatted from the sky. A B-1B, while fast, would be tracked and engaged long before it could deliver its payload. Even the legendary B-2, with its magnificent stealth, would find its margin of error shrinking, its ability to remain truly invisible increasingly challenged. Its design, optimized against high-frequency X-band fire control radars, shows potential vulnerabilities to lower-frequency UHF and VHF radars, which can now detect a stealth shape, even if they can't achieve a weapons-grade lock. But in a networked battle space, that vague detection is all that's needed to vector fighters or cue other sensors. The king is in check. This is the grim, cold reality that birthed the B-21. This isn't just about replacing old aircraft. It's about maintaining America's ability to project power, to deter aggression, and, if absolutely necessary, to penetrate the most hostile, lethal airspaces on Earth and deliver a decisive, decapitating blow. It's about ensuring that America's hand remains the strongest, holding a weapon that its enemies cannot see, cannot counter, and cannot survive. It's about ensuring that when the door is kicked in, it is America, and not its adversaries, holding the hammer. Spartan emerges, the shocking revelation of clean configuration. The first B-21, Cerberus, took to the skies in November 2023, a momentous occasion shrouded in secrecy. Its maiden flight was meticulously documented by observers, revealing the aircraft laden with external instrumentation pods and a long, trailing air data probe, the telltale signs of a prototype undergoing rigorous, cautious initial flight testing. These pods, bristling with sensors, are not for show. They are critical, collecting invaluable data on everything from aerodynamic performance and air pressure to structural stress and electromagnetic signatures. This is the textbook first step in validating any new aircraft's design, especially one this revolutionary. It's the crawl phase, but then came the second, and the world changed. On April 4th, 2024, the second B-21 Raider, dubbed Spartan, emerged from the shadowy depths of Northrop Grumman's legendary Plant 42 in Palmdale. And as it gracefully, almost silently, ascended into the morning sky, a collective gasp rippled through the global aviation intelligence community. Spartan wasn't just flying, it was flying in clean configuration. Let that sink in. Let the sheer, terrifying audacity of that decision become clear. No external instrumentation pods, no visible sensors cluttering its pristine, stealth-optimized surface, no trailing air data boom to calibrate its systems. Just the pure, unadulterated, lethal silhouette of the B-21 as it was designed to be, as it will appear on the darkest night over an enemy's capital. This wasn't just a minor detail, it was a bombshell. For a second prototype to fly clean so early in its flight test program is virtually unprecedented for an aircraft of this complexity. This is the run phase, happening when most programs would still be learning to walk. It speaks volumes, echoing a profound, almost arrogant confidence from both the United States Air Force and Northrop Grumman. This isn't hubris. This is a testament to a revolutionary design and development process that has fundamentally broken the mold. Why is this so significant? Because that external gear is a crutch. It's a safety net. It provides the raw, unadulterated truth of aerodynamic pressures and structural loads, data that engineers desperately need to validate their computer models. Flying without it means the engineers are so certain of their models, so completely convinced of their simulations, that they don't need the crutch. They are effectively stating that their virtual aircraft is a perfect one-to-one match for the real one. The digital twin, a paradigm shift in aerospace engineering. Why such confidence? The answer lies in a technological paradigm shift that few outside the highest echelons of military aviation truly grasp, the digital twin philosophy. The B-21 Raider isn't just a physical airplane, it's a meticulously replicated, living, digital entity. From its earliest conceptualization, every rivet, every circuit, every square millimeter of composite skin and every sensor aperture was designed, simulated, and stress tested in a hyper-realistic virtual environment. This digital twin is not just a KD model, it's a living, breathing, evolving simulation that perfectly mirrors its physical counterpart. Imagine building a Formula One car, but before the first piece of carbon fiber is laid, you've already driven 1 billion virtual miles. You've crashed it 1 million times in the simulator, tested its engine in every conceivable condition, and optimized its performance down to the micron. That's the power of the digital twin, and the B-21 program has scaled it to an unprecedented level. Even the F-35, a digital aircraft, faced massive hurdles translating its design from the virtual to the physical, resulting in costly delays and endless troubleshooting. The B-21's process is a generational leap beyond that. It has learned every painful lesson from the F-35 and perfected the process. What this means for the B-21 program is revolutionary. 1. Accelerated development. Decades of traditional iterative physical testing, fly, test, land, analyze, modify, fly again, are compressed into months of hyper-efficient digital simulation. The aircraft has already flown millions of hours before its first tire ever touched the tarmac. 2. Reduced risk. Potential flaws, aerodynamic instabilities, or stealth compromises are identified and rectified in the virtual realm before they manifest in costly physical prototypes. The unknown unknowns that plague complex programs are systematically hunted down and eliminated in cyberspace. 3. Manufacturing precision. This digital perfection flows directly to the factory floor. The digital twin feeds its data not to human mechanics interpreting blueprints, but to advanced robotics and automated manufacturing systems. This ensures that every B-21 built is a perfect, microscopic level copy of the one before it, eliminating the tiny manufacturing differences that could compromise stealth. 4. Cost efficiency. Fewer physical prototypes, fewer flight hours for initial data collection, and a streamlined manufacturing process translate directly into billions of dollars saved for the taxpayer. This is how the B-21 has remained, almost miraculously, on time and on budget. The fact that Spartan flew clean means one thing. The data collected from Cerberus's initial flights perfectly matched the predictions of the B-21's digital twin. This isn't just a success, it's a complete validation of an entirely new way of building advanced weapon systems. It confirms that the Air Force and Northrop Grumman already possess an unprecedented understanding of the B-21's flight characteristics and stealth performance, even at this embryonic stage. The digital ghost is real, and it flies perfectly. The Invisible Killer, a deeper dive into B-21's all-spectrum low observability. The B-2 was a marvel, but the B-21 is a masterwork of stealth, designed not just for radar, but for the entire electromagnetic spectrum. This isn't just about being low observable. It's about being all-spectrum low observable, a phrase that should send a chill down the spine of any adversary. It means the B-21 is designed to be invisible not just to radar, but to heat-seeking sensors, to electronic sniffers, and even, to some degree, to the human eye. Let's dissect the terrifying advancements implied by the glimpses we've had. 1. The tail section, a symphony of thermal deception. The B-2's exhaust ports were a closely guarded secret for decades. On the B-21, the entire rear section is a testament to extreme thermal management, a direct and lethal response to the proliferation of advanced IRST systems. Infrared Search and Track, IRST. These passive sensors, now appearing on enemy fighters and ground-based systems, detect heat signatures, making radar-defeating stealth aircraft vulnerable. Modern IRSTs, operating in multiple infrared bands, can pinpoint hot exhaust plumes from extreme distances, even when a jet is stealthy to radar. Thermal masking. The B-21's exhaust system appears to be far more integrated and complex than its predecessor. The deeply recessed and highly blended exhaust nozzles are designed to rapidly cool and diffuse the engine's superheated exhaust gases. Imagine a labyrinthine internal path lined with advanced ceramic matrix composites, CMCs. These CMCs not only withstand impossible temperatures, but actively absorb and re-radiate that heat at less detectable wavelengths, spreading it across the airframe. Internal plumbing. The scorching exhaust is then mixed with cooler bypass air from the engines and ambient air from hidden dorsal inlets before being expelled through a wide, flattened opening. This trough system spreads the remaining heat signature over such a vast area that, from a distance, it simply melts into the background thermal noise of the atmosphere. It's not just reducing heat, it's spreading and masking it, making the B-21 look like a cold, dead piece of sky. 2. Next generation radar, absorbing materials, RAM. Durable deception. The B-2's Achilles heel, if it had one, was its delicate skin. The radar absorbing materials, RAM, and coatings required meticulous, time-consuming, and expensive maintenance. Even a rainstorm could damage the delicate surface, compromising its stealth. The B-21 is different. It incorporates next-generation RAM that is not only more effective across a wider range of radar frequencies, but also significantly more durable. Broadband absorption. Modern radars operate on multiple frequencies. Older RAM might be effective on X-band, but less so on S-band or L-band. The B-21's RAM is designed for broadband absorption, meaning it can defeat a much wider spectrum of radar threats, from high-frequency fire control radars to lower-frequency early warning systems. Metamaterials. This isn't just radar-absorbing paint. It's speculated the B-21 skin is an advanced metamaterial, an engineered surface with properties not found in nature. This skin can actively manipulate radar waves, not just absorbing them, but potentially bending, cancelling, or re-radiating them in harmless directions. It's less a stealth coating, more an invisibility cloak. Environmental durability. This new RAM is engineered to withstand the rigors of flight, rain, hail, temperature extremes, sand, with minimal degradation. This translates to vastly reduced maintenance time and cost, improving the B-21's operational availability and reducing its footprint at forward operating bases. It's a stealth aircraft that can spend more time in the air, hunting, and less time in the hangar, being pampered. Integrated sensors. The exterior skin itself is likely interwoven with sensors and antennae, making them invisible to radar. This isn't just skin, it's intelligent reactive armor, sensing and adapting to the electromagnetic environment. 3. Aerodynamic shaping, the art of invisible lines. Every curve, every angle, every panel on the B-21 is meticulously sculpted to deflect radar energy away from its source. But the B-21 pushes this to extremes, perfecting the principles of stealth shaping. Flattened air intakes. The air intakes for the engines are almost impossibly flat and blended into the upper surface of the wing. These are not merely S-ducts, they are likely serpentine intakes that completely hide the engine fan blades, preventing radar returns from the most powerful source on any aircraft, the rotating metal of the engine itself. Seamless canopy. The cockpit canopy, often a complex part to stealth, appears to be an almost perfectly integrated part of the wing structure with minimal seams or discontinuities. This is critical because even microscopic gaps can reflect radar waves, creating hotspots that betray the aircraft's presence. New techniques, possibly involving advanced composite molding or even electrically conductive coatings within the glass itself, are likely employed to achieve this unprecedented level of seamlessness. Planform alignment. The B-21 perfects the principle of planform alignment. All wing edges, control surfaces, and even small panel joins are angled in just a few very specific directions. This means that instead of scattering radar energy in all directions, the aircraft reflects it in just a few narrow, predictable spikes. An enemy radar might get a fleeting flash as the B-21 passes, but it's not enough to establish a track or guide a missile. From all other angles, it is utterly invisible. Size and simplicity. The B-21 is visibly smaller than the B-2, A smaller aircraft is inherently stealthier and more affordable. Furthermore, its overall design is simpler, with fewer complex curves and joins, making it easier to manufacture and maintain its stealth integrity. The Flying Data Center, B-21's revolutionary open system architecture. Beyond its physical stealth, the B-21 embodies a different kind of revolution, a digital one. This isn't just an airplane, it's a flying data center, a massively powerful, networked, artificially intelligent computer system designed for the rapidly evolving threats of the 21st century. At its core is Open System Architecture, OSA. This is a radical, fundamental departure from traditional military aircraft design, which typically relies on proprietary, black box closed systems that are incredibly difficult and expensive to upgrade. Think of it this way: your smartphone runs on an open operating system, iOS or Android. Developers around the world can create new apps, and your phone can be updated with new features and security patches every few months, keeping it relevant. Traditional military aircraft, like the BE-2 or even the F-35, are more like bespoke, integrated systems where every component is custom-made and tightly integrated. Upgrading them is like trying to change the operating system of an old mainframe computer. It requires a massive, costly, depot-level overhaul that can take years. The B-21, with its OSA, is different. Modular hardware, key components, sensors, communications arrays, mission computers, electronic warfare suites are designed as modular plug-and-play units, like Lego bricks. When a new, more advanced sensor becomes available, it can be easily swapped in, much like upgrading a graphics card in a desktop computer. Software defined. The B-21's capabilities are largely defined by its software. New threats can be countered and new mission sets enabled through rapid software updates, much like an app store for military hardware. This means the B-21 can evolve at the speed of software development rather than the glacial pace of hardware replacement. Data fusion. The true power of OSA lies in data fusion. The B-21 will hoover up petabytes of data from its own sensors, radar, infrared, electronic, and from off-board assets, satellites, drones, ground stations. Its onboard AI will then fuse this information into a single, coherent, God's-eye view of the battlefield, presented to the pilots or perhaps to no pilots at all. It will identify threats, prioritize targets, and suggest courses of action in milliseconds. Future-proofing. This architecture future-proofs the B-21 against technological obsolescence. As adversaries develop new radars or electronic warfare techniques, the B-21 can be rapidly upgraded with new countermeasures and capabilities, ensuring it remains at the cutting edge for decades to come. This drastically reduces the cost of long-term sustainment and keeps the aircraft relevant against emergent threats without requiring entirely new airframes. This digital backbone makes the B-21 an incredibly adaptable platform, a system of systems capable of absorbing new technologies and responding to unforeseen threats with unprecedented agility. It's not just an aircraft, it's a combat system that learns, adapts, and evolves. The orchestrator of the shadows, B-21's evolving role in future warfare. Initial perceptions of the B-21 focus solely on its role as a deep penetrating bomber, delivering nuclear or conventional payloads. This is its primary and most terrifying function, but the reality is far more expansive, far more terrifying for America's enemies. The B-21 is designed to be the orchestrator of future warfare, a multi-role platform that will fundamentally reshape how the US projects power. 1. Strategic Reconnaissance and Surveillance, ISR. Its unparalleled stealth, long endurance, and advanced sensor suite make it the ultimate ISR platform. It can penetrate highly contested airspace, loiter undetected for days, and gather critical intelligence that other platforms simply cannot acquire. It can soak up enemy electronic emissions, building a perfect map of their air defense network without them ever knowing it was there. 2. Battle management and command and control. C2. With its robust, low probability of intercept LPI, communications capabilities, and massive processing power, the B-21 can act as an airborne battle management node, a quarterback in the sky. It can coordinate the actions of other stealth assets, including F-35s, F-22s, and the most revolutionary aspect of its future role, collaborative combat aircraft, CCA. 3. Mothership for collaborative combat aircraft, CCA. This is where the B-21 truly enters the realm of science fiction. CCAs are advanced, stealthy, artificially intelligent drones that will fly alongside the B-21. Think of them as loyal, robotic wingmen, but exponentially more capable, expendable sensors, weapons platforms. CCAs can extend the B-21's sensor reach, flying ahead to scout, acting as decoys to draw enemy fire, or even carrying their own electronic warfare pods to jam enemy radars. Swarming tactics. The B-21, acting as the C2 node, could command swarms of these CCAs, overwhelming enemy air defenses, engaging interceptors, or striking targets with precision, all while the manned B-21 remains safely out of direct harm's way, deep inside hostile airspace. It presents an impossible dilemma: shoot at the cheap drones, or try to find the invisible mothership controlling them. The long-range kill chain. The B-21 could penetrate enemy airspace, use its passive sensors to detect a high-value target, like a mobile missile launcher, and then transmit that targeting data to a CCA, which then launches its own weapon. The kill chain is completed without the B-21 ever emitting a single detectable signal. 4. Optionally manned. Critically, the B-21 itself is designed from the ground up to be optionally manned. While initial operations will undoubtedly involve human pilots, the architecture allows for future operations where the aircraft could fly complex, multi-day missions autonomously, eliminating the constraints of crew endurance and the risk to human life in the most dangerous scenarios. This future is not decades away, it's built into the very DNA of the B-21. The B-21 isn't just about delivering bombs, it's about delivering effects. It's about denying the enemy their sanctuary, shattering their defensive networks, and providing the US with an asymmetric advantage that no other nation can currently match. It is the ultimate stealth predator, capable of hunting unseen, striking with surgical precision, and orchestrating an entire air battle from the very heart of enemy territory. The shadow of deterrence, a world forever changed. The second B-21 Raider's clean flight isn't just a technical milestone, it's a profound strategic statement. It is a calculated signal, a demonstration of capability meant to be seen. It signals that the program is advancing at an unprecedented pace, exceeding expectations, and that America is rapidly fielding a weapon system that will redefine the global balance of power for the next 50 years. For allies, it offers reassurance. America remains committed to its defense and possesses the tools to enforce peace and deter aggression in the most challenging environments. For adversaries, it's a chilling, existential warning. The skies will never be safe. The invisible hand of American power will reach into the deepest, most heavily defended territories, and there will be no sanctuary. No bunker is deep enough, no mobile launcher fast enough, no command center secure enough. The fundamental assumption of A2 AD, that territory can be made impregnable, has been rendered obsolete. The B-21 Raider is more than just a bomber. It is a symbol of American ingenuity, a testament to technological dominance, and a silent, terrifying harbinger of a new era in warfare. It is the ghost in the machine, an unseen force ready to deliver swift and decisive justice from the very edge of perception. The game has changed, the ghost is real, and it has just shown us a glimpse of its terrifying, unblinking, and unstoppable future.